All right, so here we are on the final part of exam 3, part 6. And what we will be doing in this one is implementing the Crank-Nicholson method, and which we worked on in the previous part. And then we'll be plotting the temperature profile as a function of time. Exciting stuff. So we'll start this one off kind of similar. We will import numpy as np. We also need to import the subplots, since that is the main goal of this, getting a subplot at the end. Plotly.subplots. From plotly.subplots, import make underscore subplots. Now, the different thing that we're going to have to be doing in this one is we're doing from scipy dot linalg, if you want to call it that, and then we're importing solve underscore banded, and this just allows us to solve our banded matrices that we will be doing later. So, slow internet again, there we go. Now we can move on to defining some of our variables. So we have nx, which is our number of nodes, and we set that equal to 100. Then we have nt, which is the time steps, time increments we have, and that is set to 2000. Then we have alpha. Always struggle typing alpha for some reason. That's set equal to 1. Oh my goodness. Okay, and now we have dx, which is set to 0.5, dt, which is also set to 0.5. Shift enter. Good, nothing wrong. Now we are able to do our spatial increments. So we can type x equals np dot range, and then we'll do the number of nodes, time increments, and that is multiplied by the change in, I'm sorry, yeah, the number of nodes times the change, yeah. All right, and then we have a variable r as well, and that is equal to alpha times dt divided by dx, and our dx is squared. But the different thing in this one is we are also then dividing by 2. So we shift enter. That is okay. So now next step is we are going to create an array for our temperature. So we'll do t equals np dot full, and then we want to use our array to be the size of our nx, which is our nodes, 100, and then we want it to have a value of 20, each one of those to have 20. But that would just make everything have 20, and in our case, our initial, which is t0, since Python's indexing starts at 0, is going to be set to 50, and then our last one, which is t of -1, the last one, is going to be set equal to 80. So we can shift enter on that. Looks good. And then we can, just for reference, do t, shift enter, and then in our array we have 50, rest 20s, and then the last one 80. So it's looking good. Now we can move on. All right, so now we are going to make another matrix, this one being called A, and this is going to be a multi-layer matrix. So we will do A, and then we will set it to np.zeros. So this will have 2 dimensions, and this is done by doing 3, and then we take our number of nodes, and then we'll subtract 2 from that. So now we need to set in a couple parameters. The first one that we are going to be setting is a equals a of 0, 1 is equal to -r, and this is for our main diagonal of the matrix. Now we have a of 1 comma, and then we don't have anything there, just semicolon or colon, and then this one is going to be equal or set equal to 1 plus 2r, or 1 plus 2 times r. I apologize for that. And this is going to be our main diagonal. And now the last parameter we're going to set up is for our lower diagonal. So we have 2, then we have -1, and then this is also going to be equal to -r. So we'll shift enter. All right, no errors. So now we are going to create another matrix, this one being slightly simpler with what it looks like, but not what we have to do to make it. So this is B, or we will be calling this matrix B. So we can do this by setting it equal to np.zeros. And then in this one, it's just nx minus 2 because it's not multi-layered. And this just allocates the vector of RHS of a set of linear equations. So now we can do B equals R, and then now we're just basically putting in formulas from part 5. So we'll do B equals R times T of 2, and that is going to be added to 1 minus R2, I caught that, 1 minus R2 times R. And this is going to be multiplied by another temperature, 1, -1. And then lastly, it is going to be added to R times T of -2. So now we can do B of 0 is, okay, that was weird. B of 0 is equal to B of 0, but it is being added to R times T of 0. Last parameter we're going to set up is for our final number in the, so the B of 0 was like that's our initial value in our matrix. There we go, that's the name. So now we're doing our final, which is B of -1, and that is being set equal to B of -1. Jeez. B of -1, and that is being added to R times T of -1. Shift enter on that. Okay, so now that we have our two arrays, we are going to make subplots for both of them, and we can do this by doing fig equals make underscore subplots, and then we'll set the rows equal to 1 and the columns equal to 1. And then now we just do fig dot add underscore scatter, and then we will do x equals x, y equals t. We'll set the name of this one equal to crank.n for Crank Nicholson, or dash n, and there we go. Shift enter on that. And this is just the basic one. We will be adding more things here in a little bit to make it look a little bit better. All right, so now that we have both A and B matrices made, we can now create a for loop, which will allow us to get our final plot. Excuse me, so we started off by doing for I in range of the number of time increments plus 1. And then we can now, now we do t of 1 to -1. and that is being added to our 1 minus 2 times r, and then that is going to be added, or I'm sorry, multiplied by t of 1 to negative 1. Finally, that is going to be added to r times t of negative 2. So, okay, negative 2. There we go. So now we can just go ahead, and I'm going to save a little bit of time, just copy and pasting these b things into our for loop. Make sure that they are tabbed in though, or else it will, not double tab, single tabbed in, or else it will not work. So now, so now we do another if statement, and this is the one that we did before. This just makes sure that our values are all equal, or in terms of hundreds. And lastly, we do fig.add underscore scatter, and then we'll have the x equal to x, the y equal to t. The name of this is then going to be equal to f of I times d of t, and then we'll have an s at the end. Close off the single parenthesis, or the single quotation, parentheses. So hopefully, shift enter, no errors. Now we do fig. And something does not look right. Let me figure it out, and I will be right back. Okay, so I think I figured it out. For some reason, I just retyped this line right here above, whereas this line is completely something different. This is supposed to be t of 1 colon negative 1, and then that is set equal to solve underscore banded, and then we have 1 comma 1, and then we have comma a comma b. Okay, let's run that, run this. All right, there we go. So you can see that I fixed what was wrong. We have starting at 50 right there and ending at 80 on top. So that is it for exam 3. Thank you very much for watching, and I will hopefully see you in the future. Thank you very much.